Alright, the lab for this week, which happens to be the last lab, is the synthesis of aspirin. We are going to begin with salicylic acid, which is a carboxylic acid. And so if you were to provide a name for that, you can perhaps envision this is going to be orthohydroxybenzoic acid, another name, the IUPAC name for that. And we're going to treat it with acetic anhydride in presence of couple drops of acid. So the proton source here is just concentrated sulfuric acid. In the past we have used concentrated phosphoric acid as well, but in this lab we are going to utilize sulfuric acid. So let's take a look how it's going to happen, how the reaction proceeds. Mechanistically, hopefully you can see first the activation of the anhydride is going to take place. So you're going to get oxygen with a positive charge. That makes it even more this carbon even more electrophilic than what it is otherwise. And so your phenol is going to attack. Electrons are going to move. That will give you oxygen, hydrogen, COOH. Right now I have a positive charge which is connected to a carbon which has an OH and a methyl and oxygen. And now a proton transfer is going to take place between position 1, 2, and 3. So this lone pair can pick up that proton, and you're going to get COOH, oxygen, oxygen with an OH, there is a methyl, and we have OH with a positive charge. So that makes a good leaving group. Lone pair kicks in, this group goes away, so your acetic acid flies away, and first you end up with the protected and protonated ester, which is not going to be very happy right now, but you have the bisulfate which can pick up the proton, relieve the positive charge, and you're going to end up with OCOCH3 and COOH, which by the way is aspirin. Alright, let's take a look mechanistically. Would this be possible, first of all, in presence of a base? And the answer to that is yes, it is. It is absolutely doable in presence of a base as well. In that case, however, it doesn't go through activation of the anhydride, but rather activation of the nucleophile, and that is what allows the loss of the proton and then the attack. But anyway, we are going to follow the acid catalyzed reaction. So let's take a look at procedurally how this is going to pan out. What you'll do is you will begin with 2.000 grams of salicylic acid. So if I were you, I would keep my observation table ready. You can at least do that for one of the labs. This is the last lab, so hopefully you will be able to organize your thoughts and your data ahead of time. So you will have one column that will say mass of watch glass, and again I have provided you the dummy observation table throughout the organic one as well as organic 2. Mass of watch glass, you're going to write that here. You're then going to say mass of watch glass plus salicylic acid That's going to go here, and then you'll see a mass of salicylic acid, which is essentially B minus A, and that will be the third number. This number is what we are saying is going to be approximately close to 2 grams. It doesn't have to be exactly 2.000, could be 2.5, could be 1.5. Your yields are dependent on the moles that you begin with, so don't worry about trying to get it exactly at 2 as long as you know how much you're taking. Now, since this procedure is optimized for 2 grams, the closer you are, so rather than having a 1.5, I would try to keep it, 1.8, 1.9-ish or so. And then you're going to this particular 2 gram salicylic acid in an Erlenmeyer flask. We're going to take a 50 milliliter Erlenmeyer flask, and we're going to put that in. We will then add acetic anhydride to that. Acetic anhydride. And then we are going to add 5 drops of sulfuric acid, concentrated sulfuric acid. It's a good idea to add this dropwise. It's also a good idea to swirl this very gently, do that in the hood, and concentrated sulfuric acid, I don't have to specify. It's a very strong acid. You have to wear gloves, and if you get a drop on yourself, on your glove, it is going to eat away that glove and is going to go through. So you will have to put your hand underwater for a very long time. I might have to call emergency medical services if there is a burn involved. Please do this very, very carefully. Once you have added the 50 milliliter in the 50 milliliter flask, once you have added the 5 milliliters of acetic anhydride and the 5 drops of concentrated sulfuric acid, you will swirl it, and then you're going to gently heat it on a steam bath. You can also use a water bath, that works just fine. They have to be maintained. The water bath has to be maintained at 50 degrees Celsius. If you plan to use the water bath, my suggestion would be that you should use a beaker, just so that the water bath gets heated, quicker. Make sure that you have a thermometer inserted. So let's see what that will look like. Let's see a picture of that. So if you decide to use a water bath, here's your beaker. Probably a 400 milliliter beaker would be good, filled halfway through. Here's your stir plate. You want to select a number, not 50. There will be loss of energy, so you must put a thermometer inside to maintain. So make sure you clamp that thermometer. It should take the temperature of the water, not of the walls of the container or the bottom of the container. And then you can put your flask. Usually this flask would not, sit all the way in, but it would rather be kind of a little bit tilted on the side. You can use a steam bath. You will basically have all your rings in place, fill it halfway through, and put in your flask like that. I like the steam bath better because everything is, nicely sitting on top of where it's supposed to be. And you have to heat this for at least 10 minutes. At least 10 minutes. Usually, this 10-minute period does get extended to about 15 to 20 minutes. So this is the time that we are going to work on the 2 wiki problems. We only have 2 students who have to go through essentially 5 problems apiece. So we have to go through 10 box problems or prepare questions, and that's what we are going to spend the time while you guys wait for the heating to go on. One of the partners should still keep an eye on the flask, because after the 10-minute period or the 20-minute period, usually the precipitate starts to appear, and you are supposed to cool it at room temperature. So just keep an eye on it. If it's ready, just remove the heat and allow it to cool. As it cools down, the precipitate should start crystallizing, and you might have to essentially put an ice bath to maximize that precipitation. As the crystal formation occurs, as it gets completed, and you can tell that from, you would start with a clear colorless liquid and a solid would have appeared. You're going to, while it is still cooling in the ice bath, so let's see what that will look like. You will have your ice bath, you will have your flask, you still have your ice. Okay, it's completely submerged. So while it's still cooling, I want you to add 50 milliliters of water, and I want it to be as cold as possible, so cold water. The reason we want it cold is because, recall, we had added a catalytic amount of acid, and we are trying to essentially get an ester. But if we don't pay attention, we might actually hydrolyze our ester back. So we don't want that to happen. We want to try to keep it as cold as possible. So while one of you took the time to setting up your hot bath to form aspirin, you should also take another flask or a test tube with about 50 milliliters of water, which you should just put in ice to have it as cold as possible. By the time you need it, it would be nice and ready. Now, we are going to go ahead and carry out a vacuum filtration. So that's just a regular Buckner funnel assembly, which you're going to use. So once you're ready, you're going to collect the crystals on the filter paper on the Buckner funnel, and you're going to rinse the crystals several times with small portions of cold water. Again, this water has to be water for washing, has to be cold. Has to be cold. You don't want to hydrolyze part of your product. And as you're doing that, you'll continue to allow the vacuum to pull off any free solvent. Usually the step, as always, takes about 5 to 10 minutes. Is what you would get. And then you're going to just air dry your product. Your yield will be calculated as a crude aspirin yield, considering that this wet cake that you're going to get on top of your filter paper, so it will be pretty cakey. Will not be, the usual solid that you get, which is shiny, but rather very cakey because this is crude. You will assume that 50% of that is water and only 50% of that solid is your product. So when you take the mass, the yield of this, let's say you end up getting 3 grams. Okay, let's say this mass is 3 grams, which is the wet solid. You would say that in reality only 1.5 grams belongs to your actual product. So in order to calculate your percent yield, you will use 50% of it, not the mass that you are seeing on the scale. After you have your material with you, the last step is to recrystallize it. So what we are going to do is, and by the way, all of this reaction, the heating process and everything, that's going to happen in the hood. Again, acetic anhydride smells pretty much like, acetic acid. And if you don't do that, basically all of us will smell like vinegar. So let's try to keep that contained in the hood. But you can bring it outside for the washing and all of that. You can bring it outside. At that point of time, like I was saying, we were talking about the recrystallization. Recall, recrystallization as a technique is a method to purify your sample. So what you will do at this point of time is you will, let's say you have this cake, this is the cake. I want you to save only 20% of it and use the remaining to recrystallize. Okay, that didn't look like 20%. So we are saving 20%, and we are utilizing the remainder. And the 20% we are saving is just in case you lose everything else. At least you can get your your IR or your melting point from the crude, and you can have something to report. So what I want you to do at that point of time is collect all of your material and dissolve that in hot ethyl acetate. This has to be minimal amount of ethyl acetate. Recall from recrystallization. If you add too much of ethyl acetate, it's not going to come out. So no more than 2 milliliters. Now, if all of it goes in while it still is on the steam bath, so you shouldn't remove your steam bath from the hoods. While it is still in there, you might be, if you see that all of your material kind of goes into ethyl acetate, then you might be able to add a little bit of petroleum ether, along the sides, but when you cool it down, your aspirin should recrystallize. Realize that this has to be a continuous heating in order to recrystallize, and you want to make sure that you have a saturated solution. If your solution is not saturated, you're not going to see the precipitation of your product. So it's a very good idea to keep the volume of the solution as low as possible. You might also see that as you add your ethyl acetate, your solid will go in, and maybe some oily droplets are going to appear. Those oily droplets are nothing but unreacted acetic anhydride. And so depending on how much is in there, I might have to ask you to use a dropper to pull that away, so that it helps in the crystallization. But if there's only one or two, then you don't have to worry about it. It should still work. As you cool the mixture to the room temperature or in ice bath, you should see the crystals. So once you have your flask, you have your sample, you have the 2 milliliter of ethyl acetate. We heated it in a steam bath. You have to shake continuously. You have to actually watch. So this is not the time when you can run wikis. Wikis should have been done by now. And hopefully you will have a clear solution, and that you're going to place in ice. And as you allow that to happen, you're going to see essentially a white precipitate which will appear. And you are going to then collect this newly crystallized product. You're going to collect that in a Buckner funnel, and you're going to then basically, if you don't see that, by the way, before I go to the next thing, if you don't see that, you might have to add a couple drops or a couple milliliters of cold petroleum ether to aid the crystallization process. Any waste will go in the waste container, of course, and what you collect now is going to be pure after filtration. Filter and dry. You're going to take the melting point of this pure aspirin sample, and you would then be able to answer the post-lab questions, of course, in your own time. We will take an IR of this. I will provide you the IR of salicylic acid, but you will be taking the IR of your sample of aspirin, and you'll do the comparison, of course. You'll discuss the 50% yield, and you'll discuss the melting point of aspirin, and that is what you're going to report in your report. So just to kind of, again, make like a little schematic perhaps so everybody is on board. Our first step is we are taking about 2 grams of salicylic acid. We are adding about 5 milliliters of acetic anhydride, and I'm adding 5 drops of H2SO4. This is concentrated H2SO4. All of this is done in a flask. Usually we take about 50 milliliters of the flask is what we usually use. Erlenmeyer flask. We sometimes have also used 100 milliliters, but that doesn't matter. The idea is that it should not come out of the solution. We are going to swirl it, and we are going to heat it in a water bath. We have to maintain 50 degrees Celsius and at least 10 to 15 minutes. That has to be given. When you cool, crystallization should occur. Upon cooling, crystallization should occur. Crystallization. And then you cool it for another 10 minutes in the ice bath. And then you will add 50 milliliters of cold water. And then you will filter. After we have filtered, we are going to rinse it a couple times, maybe 3 times, with cold water. Cold water rinse. And then vacuum dry. Vacuum dry. You're then going to recrystallize in ethyl acetate, only 2 milliliters. If you see that while you're recrystallizing, it doesn't quite dissolve, just warm it up, okay? Just warm it up, and that should do it. And then you're going to go ahead and do the IR and get the melting point, and that's what you're going to report for your as your final report. So percent yield, we're doing percent yield. We are doing melting point of salicylic acid and aspirin, and we are doing IR analysis of salicylic acid and aspirin. That's what we are going to do. Okay? All right, see you in class.